Hey, 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 everybody. This is Simon Maple here, calling you from some part of London. Just kidding. This is Oliver White, your friendly neighborhood Rebel Labs geek. Unfortunately, we're sad to announce that our good friend and co-founder, Thomas Rimmer, has fallen ill due to extreme snows in Estonia. It's kind of like Winterfell up there with the summer snows and shit, so we're really sorry to announce that Thomas won't be joining us. However, our one and only Simon Maple is coming in to save the day, and since he knows about class loaders and I don't, we thought it would be best if he did the presentation. So thank you very much for taking care of your own problem, Simon.
Yeah.
It's great to have you on VJug.
Well, it's awesome to be here. I've heard a lot about the VJug. It's nice to finally be on.
Yeah, that's cool. So a couple of quick announcements. Next week, we've got a pretty awesome session going on. It's another panel. We received only good feedback from the last panel, so if we're not sure if the panel thing is the way to go with you guys, please let us know, though. It's always good to hear this stuff. Just tweet it right out at us. We're not shy. However, next week we're doing a special panel with our friends Arun Gupta, Marcus Lagergren, Josh Long, and Alex Snaps. We are going to be discussing the 2,164 developer responses that we collected from the Rebel Labs Tools and Technologies report. There's a ton of data in there. We're going to be analyzing it and producing more content related to all the different 14 tool segments and technology segments that we reviewed. The coolest thing is that we've got a little partnership going on with DevOps for Kids. If you don't know what DevOps for Kids is, it's DevOps for Kids. So it's cool. For everybody who logs in and checks us out, especially in the first part of it, we're going to donate $1. And luckily, we've got some support from the ex-Rebel team at Zero Turnaround. They're going to be donating $1 to match it as well. DevOps for Kids is looking for about $750 to get some Lego EV3 children's kind of interactive play sets so that the little kids of these days can be the badass hackers of tomorrow. That's about it. Please spread the word for the next week's session. It's going to a good cause. And I think without further ado, I will hand it over to Simon.
Okay, awesome. Thank you, Oliver. So what we're going to be talking about today is Java class loaders, the good, the bad, and the WTF. So without further ado, let me grab my presentation and go full screen. So can you see my full screen?
We certainly can.
Awesome. So I'm going to be dipping in and out of presentation and demo. I'm really going to be mostly basing this on demos, so if you have any questions, please throw them in IRC, and Oliver will interrupt me very politely, and he'll ask them directly. So yeah, this was originally intended to be a joint presentation between myself and Thomas Romer, and the reason why we're good people to give this session on class loaders is really because of our background here. And the background is really JRebel. Thomas Romer was the founder of Zero Turnaround, gosh, 6-7 years ago now, and the product that really created the company was a product called JRebel, and it's a product that hooks into class loading at the JVM level. So Thomas, as one of the founders and creators of JRebel, had to fight with class loaders on a daily basis, integrating with many different vendors' class loaders in app servers and other containers, and literally solving huge numbers of class loading problems. So this is where the guys at Zero Turnaround have learned their trade in class loaders through this product. Unfortunately, Tom isn't here, so you've got the 10th or 15th best thing, which is me. So I hope I do this presentation justice. If I can't answer all your questions, I will certainly hand them on to Tom or someone more capable who will be able to give you that info. But hopefully I can. Okay, so the plan then. We're going to talk about the basics of class loading, what it actually is, how you would go about loading a class implicitly and explicitly. We're also going to look at how it's meant to work, but also some of the problems you can get, particularly in containers and enterprise Java environments. We'll look at also a very dangerous environment or a very dangerous problem which exists, which is around how class loaders leak. And also discuss why leaking class loaders is very much more dangerous than actually leaking classes. So this is what we're going to go through. I mentioned we're going to do some demo work. What we're going to do for the demos is after we talk about class loaders briefly, we're going to look at some of the exceptions that you might get during your work with class loaders. And this, you don't even need to be deep into the Classloader API to be able to get these kind of exceptions, or to see some really nasty exceptions where you wouldn't even think it actually came from a class loading issue. We're also going to show you a demo of leaking class loaders in a JGame exploding, which will be all very fun. Okay, so we're going to talk about the basics. And initially, what is a class loader? Now, many of you will not have used the Classloader or the Classloader API before because you will typically load classes in the background. So you'll let Java just load the classes for you implicitly. You'll write some code. You won't make any explicit calls to the API. But all of a sudden, classes will be available to you, and you can instantiate objects from that. You don't need to write any special code. But for many of you who do use the class loading API, and it's not necessarily something that's recommended, you should only really go to the Classloader API or delve into the depths of Classloader hell if you have a real need to do so. Here's an extract from the Classloader API. Here we have a couple of very useful and well-used methods. The most useful is, for those who have used the Classloader API, is this load class method. And the load class method essentially just takes a string, which is the concatenation of your package name and your class name. And if the class loader has access to the class on the file system, it will or in the class path, should I say, it will return you a class object, which you can then instantiate and create an actual object from. To do that, it actually uses the define class method under the covers. Which, what it does, that takes a byte array, and from that byte array it will actually construct you that class. Define class is also used if you need to load over a network or something similar to that. But both of these are methods, and there are overloaded methods of these two on the Classloader interface as well. But these are the main two. Get resource and get resources are also very useful, particularly when you're debugging problems or trying to remove your assumptions as to what problems might occur or might exist in your code. What they essentially do is they take a string, which is the location of a resource on your class path, and it will, sorry, that will actually be a package name and class name, and it will find you the URL or the location on the class path as to where the class loader found that class. So this is really useful for removing any false assumptions that you have as to what the class loader is actually doing in the background. So if I have a class name, including my package, I can call getResource, and I can find exactly which instance of my class is being loaded at runtime, given the URL back. GetResources just provides you with an enumeration of URLs. And finally, on this API, we have getParents. And this really defines or shows the structure of the Classloader hierarchy. By this I mean class loaders are certainly not flat in terms of if you ask a class loader, that will be the class loader that provides you or returns you the final class. It can ask its parents and the parent's parent and so on until you get someone who is able to or willing to give you a class definition, and then very often that's how you retrieve your classes. And we'll look at this in more detail later. Typically, if all class loaders in the hierarchy have the same behavior as to when they go to the parent or when they load a class, then we won't have half as many problems as we do in our usual runtimes as we do today. However, as this does vary between container and environment, we get a number of problems which we'll see later. Okay, so let's go to the basic implicit loading of a class. Here in example 1, we have our class called A, and that class has a do something method on it. And we make a reference to class B, and we create and construct a new class or a new object here on this third line. And then we make an invocation to do something else. Now, at this point here, where we look to construct B, this is the first time we're actually noticing this new class, class B. And as a result, we need to load the class in advance or prior to actually instantiating this object, this class. So what we're in effect actually doing is making a call into class A to retrieve the class loader that loaded class A. And we do this because we're existing here. This code is existing within the scope of class A. And as a result, we're using class A's class loader to load class B. If we were in class C or in a different class, a different method, then we would use the scope in that instance to load the class. So if we were in class C, we would use the class loader that loaded class C. If we made an invocation out to class C and tried to create the object B, we would then look to our local scope, which would in that case be C. So this is a very important premise of class loading. When we are in, we use our outer scope to determine which class loader we use to load us. Now, this is very straightforward, and the problem occurs when we are in a hierarchy whereby each class loader has a different behavior. So this is a very familiar hierarchy, I'm sure, to most of you, where we have our web applications and we're running in a container. So let's say this is a Tomcat container, for example, at the very top. And we have our applications, and here we have War 1, War 2 as part of our application. And both War 1 and War 2 will have different class loaders, as will App 1, as will our container. And when we're in War 1, if we were to make an invocation to, if we were to try and create a new class, we were trying to load our class in War 1, rather than go to our parent first, what we would actually do is look locally first within the local class path of our class loader in War 1, and we would try and load the class which we were trying to load first locally. If we cannot find the class locally to the class loader in War 1, and typically this is going to be the webinflib. If we cannot find that class locally in the webinflib, we would then go up to our parent class loader. And in this case, this would be our application. Now, this is very much the difference in behavior here. Virtually all class loaders will look to their parent first, and they will go to the highest point in their hierarchy before trying to actually load the class. When you get to the very, very top of the class loader hierarchy, and we can load the class, that class will simply just be passed down until we get back to our original caller. If we are at the top of the hierarchy and we can't load the class, we will then gradually go back one by one until we can load the class on the class loader, and then pass that back. So the difference here is in the War class loader, some application servers, not all of them, so WebSphere as an example, will actually go to parent first to load its class. Whereas Tomcat, as an example, in its War class loader or Web class loader, it will actually look to its local environment first. And there are benefits, but also failings to doing that. The benefit to doing something whereby I look locally to my local Wars class path first is so that I can introduce or I can provide libraries inside bundled inside my WAR file and use them over and above anything my container or application would want me to use. Typically in a container, if I used WebSphere as an example, if you didn't want to use the WebSphere logging environment, the Log4j service, if I wanted to use a newer Log4j service, I could package that into my WAR file, and I could set my environment up so that I look locally first into my WAR file, and I could get my web app to then use my local Log4j implementation before going up to the container and using the packaged WebSphere implementation. The disadvantage, of course, is if we set up a container, if we set up our application server so that all our web class loaders load locally first, then if I have a common class, I will be looking and potentially loading the same class in every single WAR file, in every single web class loader, rather than just going up to the main common container or main common application and load it once. This is also another sticking point whereby we can see problems. So this is one of the crucial parts as to how we're going to see potential problems in our future demos. If there's any questions on this, Oliver, any questions so far on any of this structure?
So far, there's a few comments, but I think that they can wait. Okay. One of the questions is is it wrong to specify Tomcat for EAR deployment? Tomcat is only a web container.
Yes,
I thought. Oh.
Yeah, I thought that straight away as I said it. Consider I said WebSphere there.
Because that's what everyone wants to use. So yeah.
Absolutely.
Good. All right, that's clear.
Perfect. So, okay, intentions then. Just to summarize what we've talked about so far then. So class loaders have a parent class loader. Every class loader is a class. And what loads a class loader? Well, it's a class loader. What loads the very, very first class loader? Whoops, sorry. What loads the very, very first class loader? Well, that's a bootstrap class loader. The parent is typically consulted first, so the best practice is to go as high up in our hierarchy as possible before trying to load a class. That way we have fewer classes loaded and more flexibility, as we'll see later. However, in a Java EE web module, local classes are searched first. So if we are in a WAR file, we will look locally to that WAR file. So this is typically the webinflib, to see if we can load resources first there before going up the hierarchy of class loaders. Okay. Now let's delve into our problems. So,
hey Simon.
Hello.
Can I introduce you? Can I interrupt you for a second? There's a question posed that I think is related directly to what you were just saying. Will the class be loaded locally first, or will it pass the loading to the parent in the hierarchy?
So this depends on whether you are a web class loader or a regular class loader that delegates to the parent, or whether you're a web class loader. If you are a class loader that its default behavior is to go to parent first, then it will go as high up the hierarchy as it can, then try and load from the very, very top. It'll try and load that class and pass that class down. If you're a web class loader, you will try to load that class first locally, and if you can't load the class, then you will go to your parent after that, and your parent will typically delegate up, and then you will have the topmost or lower class loader loading your classes from there. Hope that makes sense.
Alrighty.
If not, drop me again. Cool. Okay, so what I've got here is I've got my Eclipse environment, and in my Eclipse environment I have a Tomcat server which I'm just managing with Eclipse, and I have an application in my or a project in my workspace, and these are just a bunch of servlets. I have this deployed onto my Tomcat environment, and so basically what I'm doing is I'm going to run a bunch of code which is typically going to drive us, which is typically going to pull up some class loading issues, class loading exceptions, some of which many of you will have seen before, possibly even today. Some you may not have seen before or may have been entirely perplexed by and never really got over them. So the first one is my servlet test1 here. And all test1 is doing is it's making an invocation to util1, and we're creating a new object util1, and then we're making an invocation of that to the say hello method. So if I click through on util1, we can see the say hello method exists, and we are just returning a string. So we shouldn't expect anything to go wrong there at all. But if I come across to my, in fact, let's just close a few of these. If I go to my web browser now, I'm going to go http localhost 8080 cldemo/test1 drive this. We see straight away that we get an exception, and this is a very, very familiar exception to many. No ClassDef found error util1. I'm not going to ask any stupid questions as to what this means, because I'm sure everyone on this call has seen this before. But what I want to do is I want to show you how we can diagnose these problems better, how we can get information about the problem to better understand our scenario. Because one thing that I think is very common is that we assume we know our environment. We assume we know what's going on in the runtime, and this is often something which is quite different. What we actually think is happening in the runtime is not always what actually happens in the runtime. But what I can do is I can come in here and I can say, okay, let's comment this out. Let's do some investigative work here. What we're going to do is we're going to grab the util1 class is actually going to be loaded in the scope of test1. So we know test1's class loader here is actually being invoked to get this util1 class. So what I'm going to do is I'm going to call test1.class, and I'm going to get the class loader from that class. And this is really key. This is the first important part. Every class that has been loaded has a direct link back to the class loader that loaded it. Now, because of this, we can work out which class loader we are actually going to be calling to try and grab or try and load the new util1 class. So we can get the test1 class loader, and I'm going to cast this to a URL class loader. And this is a very, very common class loader which exists in many runtimes, and this is Tomcat. It exists in Tomcat runtime, and I'm pretty sure it's going to be in most application servers. One of the great methods of the URL class loader interface is get URLs. And what this provides us with is a full list of URLs which that class loader can see for its class path. So if I comment that out, I hit save, and I just come straight back here and reload my class. What we can see here is our full class path, and we can see that we have in our CL demo webinf classes, we have that on our class path, which is to be expected, and we also have a webinf lib CL demo.jar, and I believe that my util1 class is in this jar. So what I can do, I can copy this, and I can cd directly into this location. Let me just remove everything there. So I can see everything is in here. What I can do, I'm going to jar minus tvf, and we can see straight away that util1 does not indeed exist in here. And this is a very, very simple environment. So I could for instance have well known that what I actually haven't done is entirely exported my dependencies correctly and put them in my runtime. But if this is a more complex environment, I could maybe try and see exactly which jar it should be in, whether it's in there or not, whether that jar is on the class path, and that kind of thing. So what I really want to hammer home here is the fact that we want to We want to verify our assumptions, make sure that what we're seeing is actually what is happening under the covers.
Hey, Simon.
Yes.
Can I chime in real quick? Is there any way you can increase the font size here? It's kind of difficult to see.
That's a good
Especially
point.
now.
I could probably do that. Actually, let me. The easiest way I could probably do that.
I think we just wrote a short report describing a shortcut for that, didn't we?
Did we? Let me. One thing I could almost certainly do is that. And is the Java code good, or would you like that bigger as well?
I think everything as large as possible until it gets
as large as
reasonable should be a good thing.
Okay, so let me update my preferences. How's that? Is that okay? That looks better. Okay, right. So let's move on to a slightly more interesting test. Let's go on to test 2. Okay, so what we're going to do now is, instead of using util 1, we're going to be using util 2. Util 2 pretty much does the same thing. Got say hello, returns hello, everything looks good. We can see from when we were in our war file back here, we do have a util 2 existing on our class path. So the class exists. We should be able to load our class now. Let's now go back to my go back here and run test 2 to see, and we get another exception. This is where I needed a tiny bit slower, a tiny bit smaller. So our exception now is that we get a no such method error exception. So the runtime is pretty much saying the method say hello does not exist on util 2. I'm sure again this is something which pretty much all of you have seen. I'm not going to explain what the problem is. I'm sure you all know that this is because of something stale or something not high enough from the class path. But one of the things that we want to do is, how do we validate that? How do we verify that what we're seeing is what we expect to see? What we can do, we can come back to our test 2 here. I'm going to comment out our invocation, and I'm going to uncomment this. What we're going to do, util 2 has been created and has been instantiated in the scope of test 2. So we're using test 2's class loader to do this. So what we're going to do is we're going to grab the class loader of test 2, and we're going to call getResource. We call getResource because we know we are getting at least some version of util 2, because our exception isn't saying we can't find util 2, it's we can't find a method on util 2. So we have the class util 2. So we want to get the resource. What we want to do is we want to get resource util 2, and we're going to get names. This is going to be the package name and the class name, and we're going to replace dots for slashes and add a dot class. What we're effectively doing is changing this from a package and class name into a fully qualified path on our file system. So if I save this, come across and refresh this, make that a bit bigger, what we see here is a fully qualified path. We can see that we're going again into the into our web apps, into our CL demo application, into the webinf lib. We're going to our same jar, and we're using the util2.class. So we know, we can tell for a fact that the location which our runtime is picking up our class is from this jar. Let's look into this jar now a little bit more depth. Not tar. Let's xvf. Oh gosh, how do I use tar? Let's jar. Let's see. Let's grab you, and let's grab you from there. Let's see if that works. No, it doesn't work. It's the wrong way around. See, as an evangelist now, I don't tend to use these that much. Here we go. So we've inflated test util2.class. Now if I look at that, if I wanted to actually look into that and see what we actually have in that, I'm going to use something called Java P. I'm not sure if many of you have used Java P before, but from there I'm going to say Java P util2, and what this is going to do is it's going to look into my class file. It's going to read my bytecode and show me what I've got in terms of my bytecode. Here I can see that, okay, my bytecode is showing that we have a public class. It's called util2, and we have a default constructor of util2, but nothing else. So we don't see a say hello method. I was never expecting to see a say hello method here because my runtime is telling me that I am using this class. This is the class I am loading, and say hello exists. So I'm not expecting to see that, although I guess this is class loading, so stranger things have happened. Let me increase the font size there as well. So stranger things have happened, but this is a useful tool, Java P, and what I'm actually going to do as well is I'm going to extract util3 as well and show you a util3 Java P as well. In util3 we have a class which has both a default constructor as well as a method that returns us a string. So in util3 we can see what we would have expected from util2. I'm also going to show you something else which is kind of funky. I think it's -c. Yeah, if you're interested in Java bytecode, -c actually shows you the line by line instructions that are going to be interpreted. Here we can see in my class we've got a public class util3. We've got a default constructor, and what we're doing is we're loading that constructor. We're making an invocation directly into that constructor. Invoke special is I'm pretty sure my bytecode knowledge isn't up to scratch, but I'm pretty sure invoke special is only used for constructors. But here we have another method, say hello. LDC is a local load, load of our string hello, and then we just return that string directly. So if you're interested in bytecode, do have a look. We've also got a bytecode. The Rebel Labs team did a bytecode report, which I'm sure Oliver can send out as well. Okay, so any questions on anything we've done so far, Oliver?
As soon as I unmute myself, I will verify. So far, it looks like people are following with you, and okay. Now since the font size was increased, everyone seems to be happy.
Excellent. Okay, excellent. Right, so let's move on to another example. This is now we're going to get into some more fun examples. This is an example whereby we're all Java developers, right? So we all use factories because that's what Java developers do. So what I'm doing here is I'm going to call into my factory from my test3 class. I'm calling into my factory and I'm calling instance untyped. If we go into that method, instance untyped simply creates a new object of util3 and returns that as an object. So very, very simple. We wouldn't expect anything to go wrong. We cast that from an object to a util3, and then we call say hello off that object. If we have a look at util3, there's a say hello method which has a string on it, and we just simply return hello. We know util3. That's what we've got on util3 because we can literally see the code here. This is the code that is going to be loaded and run. Okay, so nothing that we expect to go wrong here, right? Let's go to our browser and run this. And by the way, this is probably one of my. If you could name your favorite exception, this is my favorite exception of all time. util3 cannot be cast to util3. That's an interesting one. Let me. I'm going to ask a question. If anyone and we'll see how this question goes, because I'm sure a lot of people. I'm sure there's going to be a slight delay between IRC and the Google Hangout. But for anyone who has never seen this, let us know first of all if you have seen this or not. For anyone who hasn't seen this before, what do you suppose this means? util3 cannot be cast to util3. Okay, I'll give you another clue. The bytecode here for both these classes could be absolutely identical. util3 cannot be cast to util3. What does this mean? Let's go and have a look at our code again, see if we can see any further clues. We have util3. Okay, util3 is there. There's only one instance of util3 in our IDE here, in our code. We call into a factory3. Factory3 is available. We can click into factory3. We have a number of methods. Util3 that links to exactly the same class or exactly the same instance in our IDE. So no problems there. We return that from this instance untyped method. It returns as an object. Okay, no biggie there. But when we come back, we cast that to exactly the same thing, exactly the same class, util3. If we look here, util3 is actually in the same package. So there's no need to do that import. In our factory 3, it's exactly the same thing. So nothing out of the ordinary. Is there anything on IRC with examples with potential suggestions?
Well, I think Mr. Rod Cortez has some answers right away, because classes get loaded in different class loaders, and the class in the VM is not the class name, but the class loader and the FQN of the class.
Yes, and this is
Rod Cortez's projection.
Well, that Rod Cortez is a smart cookie, isn't he? We need to employ him. Yeah, this is one of the big things which many Java developers don't catch on to. And this is the fact that the identity of a class is made up of 3 things. The identity of a class is made up of the class name, the package name, but it also has the identity from the class loader which loaded it. So if you have 2 different class loaders, which are each loading exactly the same class, so the same class name, the same package, and even the same bytecode, because they have 2 separate class loaders, the runtime will consider them as entirely separate classes. Seems crazy. Let's have a look at. Let's go back to our keynote presentation, just because I want to show you. Where is it? Here. Just because I want to show you what is actually happening. This is what we're using as our potential diagnosis for what's happening. Here we're in our web class loader. We're in the web class loader, which is in the scope of test 3. So this is effectively our servlet. We want to make an invocation. We want to create util3. But first, we're going to do it via a factory. So we try and do a load class of factory 3. So on our web class loader, we say, can you load factory 3? Because we go locally first. Web class loader says, no, I can't find factory 3 on my class path. I have util3 and I have test 3, but I can't find factory 3. But I'm looking locally first. Because I can't find it, I'm going to delegate up to my parent class loader. And this is the shared class loader. Now the shared class loader looks on its class path and it says, yes, I can find factory 3. I'm going to load factory 3 and I'm going to pass you back factory 3. So still in our servlet now, still in test 3, I say, excellent, I have loaded factory 3 now. I am going to make an invocation into factory 3 and I'm going to call this instance untyped method. From within that method, we try and create a new object called util3. Now, because we're in the scope of factory 3, we're going to use the same class loader that loaded factory 3 to load util3, the class util3. Now, the class loader which loaded factory 3 is the shared class loader. And it just so happens that we have util3 on the shared class loader. So we can, on the shared class loader's class path. So we can say, yes, this shared class loader is going to load util3, and now the identity of that class is the class name, util3, the package, which happens to be the default package, but also the identity of this class loader. We return util3 back from factory instance untyped as an object, and now we try to cast back to a util3. But here, in our test 3 scope, this is the first time we're seeing util3. So we're going to try and load util3. Now, where does the web class loader try and load? Or, no, in fact, first we need to pick a class loader to load util3 back in test 3. So we're in the scope of test 3, so we use test 3's class loader to load. And that so happens to be this web class loader. Now, the behavior of the class loader in the web environment isn't to go to parent first. If that was the case, we'd be fine. The behavior of the web class loader is to go locally first, to look locally first. And it so happens that we have util3 locally as well. This could be identical bytecode to the class which the shared class loader loaded. However, the identity of util3 is the class, the package, which are both identical, but also the identity of the class loader, which in this case is different because we're using two entirely different class loaders. So at this point, when we come back here and we see util3 cannot be cast to util3, it may look like an incredibly ridiculous and stupid exception. But actually, under the covers, what Java is doing is saying the identity of this class util3, this first one which the shared class loader has created, is different to this instance of the class, which is created by the web class loader, and I cannot cast between them because essentially I consider them as two entirely different classes. So that was just our guess. It was a very, very good guess because it's right. But if we didn't know that, how do we actually test for that? I'm going to comment that out, and I'm going to uncomment these two lines. What we're essentially doing here is we are saying, okay, I know the two different places which are accessing this util3 is test3 because that's where I'm doing my cast from, and also factory3 because factory3 is the piece of code which actually creates the class and instantiates the object. So I'm going to take these two scopes. I'm going to grab the class loaders from them. So we're going to have test3's class loader and factory3's class loader, and we're going to call getResource. We're going to get the same resource, util3.class.getName. We're also going to replace dots for slashes, and we are also going to add .class. So we're effectively going to say exactly where on the file system, are you looking up both these instances. So let's make that save. Come back to my runtime. Click on that, and we can see straight away. Aha! Yes, the first instance, which is let me see. The first instance, which is test3. Test3 is grabbing util3 from our webinf lib directory from the Classloader demo jar. So that's actually grabbing it directly. This is the bytecode which we've just loaded. However, the second location is the true shared class path. This is on the Apache Tomcat lib directory. So if I do a quick look in here, we're actually looking at a class in here. So if I jar minus tv to minus b, this is the class which our factory is loading, and that's the key difference. Any questions at all on that?
I'm looking. Let's see here. If util3 implemented serializable, could we translate between the two?
Could you translate between the two? No, you still couldn't. That would still be a problem. There are other ways of fixing. So to fix these, you could let me think. One of the things that you could do if you wanted to fix something like this is either to try and at the stage where we are loading, let me see. It's a bit messy, but at this stage, one of the things that you could do is when we actually try and load this util3, we could actually load it using factory3's class loader. So not very nice, but that's something you could do. And one of the nicest things to do, if it's possible, is to push everything. Make sure you push all your resources in the single place. So if it's possible, is it necessary that you both have util3 at the shared class loader level and at the util3 class at the web app class loader level? Those are a couple of ways that you can potentially fix it. Anything else?
Not that needs to be answered right away, I think.
Okay, perfect. Okay, so there are a couple of other ways that this could manifest itself in the wild. Another one which I'm going to show you here is if we're still using the factory, but you'll notice that the cast has gone away. Instead of creating the util3 object and returning it as type object, we're going to create it but return it as a util3. So we're returning it as exactly the same class. When I actually run this, let me come back here. When I run test 4 here, we get a very different exception, which is a linkage error, but it's similar in terms of the problem. The problem is it's effectively doing an implicit cast at this point. So at this point, there is effectively a cast from util3 to util3. You're getting exactly the same problem, but it manifests itself as a different exception. Another one which is perhaps a little trickier is util5 here. What we're effectively doing here is we're calling instance package on factory 3. So if I call instance package, you'll notice that these two methods, the instance method and the instance untyped, they both have the public access modifier. So what we're doing here is we've got the package wide modifier. Now the package wide modifier essentially means I have to be within this package in order to have access to this method, to be able to invoke this method. So in test 5, if I were to run this at in my runtime environment, here we get an illegal access error. We're trying to access method factory3.instancePackage from test 5. These are both in the same package. There is no reason why we cannot access this other than the fact that because we're trying to access using two different class loaders, you can almost consider packages having different identities with different class loaders as well. Not that you actually load packages, but from the class you're calling. When you actually do that check, you have to be from within the same class loader. And this is a really scary one. I mean, when you get an illegal access error, this is the way I try and fix this kind of thing is by constantly trying to think, okay, my runtime must be stale, and as a result, I'm going to redeploy, I'm going to repackage and push out my changes instantly. This is one of the things that I would typically get stuck in a loop forever, not even realizing that this is a class loader issue. Okay, so the next thing I want to do is go back to my presentation, wherever I can find it. There we go. The next thing I want to talk about, we've got about 10-15 minutes left. The next thing I want to talk about is class loader leaks, and this is a really key part, which is very dangerous. And for those of you who use something like Tomcat and try and do your refreshes or your redeploys very quickly, you'll often hit permgen problems and many different things. This is all a manifestation of a leaking class loader. Now, class loaders are very well named. They load classes, they do not reload classes, and they cannot unload classes. So once a class loader has a class loaded in runtime, that class is there, period. The only way to remove that is to destroy the class loader itself. And this is very often what happens when you look to republish your application, say in Tomcat, when you're trying to do your development. Typically, you have an entire hierarchy of structure on the left-hand side of this slide, where you'll have your class loader, you'll load your class, create your objects, but then as soon as you actually make your code changes and you want to republish and see that instantly in your runtime, what you actually do when you try to republish is you create a new class loader. You create a huge new structure, depending on the size of your application. But you create a huge new structure. New class loader, you create your new class, you create your new object, and then you create or you recreate the state from your previous object to your new object. And it's at this point whereby, if this isn't done correctly, you can have links back from your new object back to your old object, and in fact your entire hierarchy of classes, class loaders, and static state will actually remain in the runtime, and every time you do a republish, this state will remain, and you can very easily have permgen issues and so on. Now, ClassLoader leaks can be all too common. What I want to do is, let me see, I'm going to go to a ZT here we go, app server. So what we're going to do here is we're actually going to do a kind of half-assed JRebel implementation. This is our app server, and what we're doing is we're going to execute this, and we're in a while loop. And in our while loop, we're going to create a new web app via our factory. And if we go in here, we're gonna loop around this every single time. And what we're going to do is we're going to create a new class loader. So throwing away our previous class loader every second, and every single time we create our new class loader, we create our new web app, return our new web app, and then from our loop, we're going to make an invocation into web app plus plus and put some system out. So web app plus plus simply. Web app plus plus simply just let me find the simply outputs version 1 and then increments the counter. So very straightforward, very simple. When I come back out of this, let's now run this application. So if I'm not sure actually how I can increase the size of this this console, but here we have flicking through version 1 equals 0, and without using JRebel, I can make changes to this class. I can go into web app, and I can change my version 1 to, let's upgrade it to version 2. If I hit save, what we're effectively doing is reloading this from the file system in our live runtime. But that's great, but the problem is we're not keeping state. We're throwing away all our own state. We're effectively creating our entire class loader structure, but not passing that state across. So one thing I can do as I go through this loop, I'm going to go to my web app server, and from here I'm going to create a new copy method. And in this copy method, I'm going to take previous state. Here we go. Let's remove that. I'm going to take every time we go through this, I'm going to take our previous state. I'm going to grab our previous counter. I'm going to copy it to our new counter. So I'm going to stop this, make our save changes, and rerun app server. Oh, one thing I do need to do is actually invoke this. So in my app server, as soon as I create my new instance, I'm going to type copy, and that's going to pass in my old web app. So okay, let's rerun this now, and we'll see that as we spin around, now we're getting our updated state. If I wanted to now make changes to this, I can go into web app. I can maybe go back to version 1. Whoops. Go back to version 1, hit save. We're back at version 1, but our state remains. So that's an important part. But what I'm going to show you is now us introducing a leak, and this is going to be a class loader leak. So if I come back here to my web app, where is it? Let's go to my web app. I'm going to create this new leak method, and this leak method here, I'm going to implement in my web app instance. And every time we go through copy, I'm going to make a reference directly into our previous object. This is going to mean that we can't throw away our entire previous hierarchy because as soon as we try and do this, reload and throw away everything, because we're referencing it, we're not effectively throwing that away. So as soon as I hit save and rerun this, rerun my app server. Now everything's still running as normal. I can update this to version 2 and that shouldn't be a problem. The state still remains. But I know that I think on around 14, 15, we're going to get an out of memory error. We're not getting an out of memory error. That's very interesting. I wonder if this is okay. Okay, we should have got an out of memory error there. I'm not sure why we didn't.
One time you want an error and it doesn't come.
I know. Can you imagine that? Okay, but it's okay. I have some history here of previous errors that I have received from this project, and we're going to look at one of these. So typically, what you would get is you'd get an out of memory. Oh, I know why. I know why. If I go back to my web app factory, right now our class loader is very, very slim. So as a result, we're not actually holding any previous state. So if I actually simulate here that our class loader is going to have a huge amount of state here, about 8 meg of state. What we've got here, this represents some static, static state on classes which this class loader can't get rid of. As soon as I hit save on that, and let's now run it. Now let's see if I can get my exception. Let's fingers crossed for an exception this time. I think it's around 14, 15 as I mentioned. And of course with our out of memory error, we're not just going to be clueless because we're very, very clever developers. So we have there we go. Here's our out of memory error. We're not clueless developers. So we're actually doing a heap dump. And this is because if I go to my run configuration, my run configuration, in my arguments here, I have this VM argument which is heap dump on out of memory error. And this is a really, really key argument which is actually quite critical to any JVM, particularly production JVMs, so that when something goes wrong, you actually have something to go on and actually understand what went wrong. So in this case, if I'm going to refresh this this environment, so I get my latest. Okay, 33365. It's actually this one here. So I'm going to open this. I'm actually opening it in I think it's a Eclipse Memory Manager or something like that. It's called. I can't remember. But here we have a DOM tree, which I can actually see what was running in my JVM just before it crashed. And here we can see there's a huge amount of retained heap, and I can dig through to see what was holding on to this heap. And we can see, okay, it's going into the class loader. Hopefully you can see some of this. And if I dig deeper, you can now see that what I've got here is a diminishing retained heap, and after every iteration we're losing 8 meg. And if I dig into this to work out where this is coming from, it's actually coming from the web app factory. And here's our 8 meg. This is our array of longs, which in this case is just representing all our static state. So this is a key example of how class loading, how leaking class loaders can be very, very bad. Essentially, you're not just leaking a class, you're leaking every single class's static state that class loader has ever loaded, and this can actually be quite a huge amount of memory. We're not just doing that once, we're doing that every single time you do your republish into Tomcat or whatever. And I can just imagine some of you are thinking, well, hey, this is surely a permgen issue, and permgen's being removed and blah blah blah. This is actually running on the heap. So yes, permgen is a lot smaller, but this is still going to be a problem. It'll just delay that problem slightly more. Okay, so one of the key things here that I wanted to just mention, just to reiterate, the class loader, this should really be a double-edged arrow. The class loader has a two-way interaction or connection with classes. Every class that you load will have a direct link back to the class loader that loaded it. But more critically, every every class loader has a direct link to every single class it loads. So when you load a class loader via a rogue class, when you leak a class loader because of a rogue class that has a reference to some other class, when you leak that class, you don't just leak the class loader, but you then leak every subsequent class or every previous class that that class loader has ever created. And it's these static fields and this static state which causes you the problems. Okay, so takeaways. So one of the big things when you have issues with class loading is to validate your assumptions. Some of the examples that we showed here were very simple. As your app grows and becomes more complex and becomes spaghettified, you will have assumptions which may make sense in your mind, but your runtime will actually be a vastly different place with entirely different workings, and could possibly be doing entirely different things. One of the most common things here is if you have a stale class. So if we go back to test 2, where we had a no such method error, this is a classic example of potentially you're actually packaging it and you're pushing it out into your runtime, but if you have two versions of that class in your runtime, and it doesn't matter how many times you're going to package and put that class out into your runtime, if that's not first on the class path, then you're never going to hit it. So validate your assumptions, work out what your class loader is looking at, work out where you are loading your classes from, and that's some of the biggest things. Leaking class loaders are that's very easy to do. If it was hard, not everyone would be doing it. Isolation is one of the biggest things. There is actually a JSR for isolation, but it's one of those things that has been around for maybe 5-7 years, but really hasn't been touched. So I wouldn't hold your breath and I wouldn't rely on that. Jerable is a tool which, yes, it can help with your reloads without needing to create an entirely new hierarchy of classes for when you want to republish or reload. So that's an option, and that's something which we make a very good living on. So if this is something that's sounds useful to you, then you're welcome to go to jerable.com and try that out.
Shameless plug.
Shameless plug. Yeah,
shameless
absolutely.
plug.
And that's it. That's everything that I had to offer. Again, sorry you had me for the session and not Thomas. I try to keep my wafflings and ramblings just to the intros, but you had me for the full hour here. If you have any questions, I'll try to answer them. I'll try to answer them now.
All right. I think a couple questions that appeared earlier on. Did you happen to show an example of linkage error?
Yeah, so the linkage error, I can show you that again. I think it's 4. Let me find 4, test 4. So here's an example of a linkage error. The linkage error occurs when you don't have an explicit cast. So here in test 4, we go to our factory, we call instance.sayHello. Whoops, sorry, let me go back one. When we call instance, we're actually returning something of util 3. So the thing that we don't need to do after we call this method is cast to a util 3. And because there's an implicit cast here, this is an example of a linkage error. So if I were to go to where's my runtime again? If I was to go to my runtime. My other runtime. Where is my other runtime? Here we go. If I was to go to my runtime here, and I were to go to test 3, is where we're. Let me just go to test 3. Test 3. So if I was to come here and uncomment this, here we have the explicit cast. If I was to run this, we would get our util3 to not be cast to util3. If I was to run test 4, which actually has an implicit cast, that's when we get our linkage error. So we get the loaded constraint violation when trying to resolve this, which is effectively trying to resolve this in the location of test 4. So this is actually although it's a very, very verbose and annoying exception, it does give you a little bit more information about what the problem could be, rather than just some crazy, throw around in circles in your mind. How am I going to fix this kind of exceptions? That's an example of a linkage error.
Alrighty. About leaks, is the behavior the same in Java 8 as there is no permgen?
So yeah, I mean the behavior is going to be different. Permgen doesn't leaks. Permgen was this kind of was a segregation of memory which could be used, and it was a lot smaller than the big heap. So typically when you have problems in your permgen, if you're leaking in your permgen, you're gonna find the problem a lot quicker because you haven't got as much memory there to. In fact, let me change to screen so you can see me talking. So you're not gonna have as much memory there to run out of. Now in Java 8, yes, the problem is eased because you're effectively going to be running on the heap instead of the permgen. But yeah, absolutely, you still can leak class loaders, you still can leak objects. You just won't see the results as quick. Well, the out of memory as quick.
All right. I believe that's all for now.
Okay, awesome. So yeah, I mean,
sorry, there's a couple of comments about where to go get some more info about class loading. Java the Complete Reference 9th edition, Java in a Nutshell 5th edition, and as it turns out, Rebel Labs actually has some reports on class loading and Java bytecode. So rebellabs.org, you can find something maybe a little bit more fun to read than a manual from Sun, but who knows? Try it all.
Awesome. So up next, let me just find out what is up next. Let's see. The next session.
Well, up next, we've got our review of the Java We're calling it the TNT report. It's the Java Tools and Technologies report. 60,000 people checked it out on SlideShare. It's blowing up. It's done amazingly well. We've got Arun Gupta, Marcus Lagergren, Alex Snaps, and Josh Long joining us, along with Mr. Maple here. It's going to be a great panel. $1 for every person who comes goes to DevOps for Kids. It's sponsored by Zero Turnaround's newest tool, XRebel. Did I get more or less everything right?
Yeah,
Simon?
No, that sounds good, and please do share it with as many people as you can, because the more
the merrier.
Every person gets a couple of dollars, and it's really important that we get we get that as high as we can, because DevX for Kids is an absolutely awesome campaign. So yeah, let's do that.
Totally.
Awesome.
Well, I guess that's it. So tune in next Tuesday, folks, and thanks for coming.
Cheers. Bye.
Bye.